So, so we've said a lot about these analytic functions. So let us find out the condition that the complex function f of z, let's call this f of z w, should satisfy such that it will be a analytic function. So u is the real part now. Okay. So u is the real part, and we have the imaginary part b. Okay, so we have the imaginary part b, x comma y. So we have the real and the imaginary part, and what conditions should they satisfy such that this function is a analytic function? So they should satisfy this function called the Cauchy Riemann equations. So the CR equations it should satisfy such that, and the CR equations are necessary and sufficient conditions for analytic functions. Okay, so this is the CR equation, the set of two equations, so it should satisfy these equations. So this is the CR equation, so boxed out. So this is the Cauchy Riemann equation. Riemann. So Cauchy Riemann equations. Okay. So now let's see how to construct an analytic function. So you given a function, you can test whether it is analytic or not. Now given a real part or the imaginary part, we can actually construct an analytic function to this method that I'm going to just show you now. So let's see how do we go about that. So we look at that using an example. So we are given the, so we're given the imaginary part is given as x square minus y square plus 2xy plus 2xy minus 3x minus 2y. So this is the given imaginary part. We're asked to find out the complex, the function f of z. So f of z now should consist of u plus I v. So we have to find u. So how do you go about finding the complex function f of z? So this is what we'll do. So first, this is f of z. F dash of z is nothing but f. So f of z is nothing but u plus iv, right? So f dash of z, what will f dash of z be? Du by dx. So this is f dash of z is derivative with respect to x. So partial derivative with respect to x and partial derivative with respect to x. So this is f of. And now by CR equations, what do we know by CR equations? So we know these things by CR equations. So we substitute the u part in terms of v. Okay, so we substitute the u part in terms of v. So du by dx we are told is dv by dy. Okay, so dv by dy. So we will substitute that here. Okay, so instead of this, I'll put dv by dy by CR equation. Okay, so I'm using CR equations to write this. So and minus dv by dx. Now from the given, so this is the given function v. Now from that we can find dv by dx and dv by dy. Okay, so dv by dx is nothing but from the given equation 2x plus 2y minus 3, and dv by dy is nothing but from the given equation minus 2z minus 2y minus 2y plus 2x minus 2. Now this is what we'll do. Now we'll put in here y equals 0 and x equals z. So wherever x is there, you put z here. Okay, in this place. So wherever x is there, you put z, and wherever y is there, you put 0. So this is the my Thompson method for constructing an analytic function. So this is how the method goes. So you put z. So this equation just now by this will now become 2z minus 3, and this equation will now become 2z minus 2. Okay, so 2z minus 2. So now we just have to substitute in the, so now we are ready with f prime of z. So this f prime of z, this is we can construct f prime of z. This is what f prime of z is. So we just substitute these values in this equation and we obtain f prime of z. So this is nothing but now 2z minus 2, the real part, plus I, and the imaginary part is 2z minus 3. So this is the real and the imaginary part. So this is f prime of z, right? This is f prime of z. So from f prime of z, if you want to get f of z, what do you have to do? You have to integrate f prime of z. You have to integrate f prime of z with respect to z. So integrate this with respect to z. So that just entails integrating this entire function now. So you have to integrate this. So you have to integrate this with respect to z. Okay, so we have to integrate this with respect to z. So just integrate it just like any other normal integration. So this is with the integration with respect to z. So treat everything else as a constant. Okay, so I also you will treat it as a constant. So you just treat it as a constant. What you will get here is, so this will become z square minus 2z. Okay, so z square minus 2z plus I z square minus 3z and the integration constant. So just this just entails integrating with the formula wherever you had z power n. Okay, so wherever you had z power n dz, you have to integrate using the formula z to the power n plus 1 divided by n plus 1. So this was the formula that was used. And just take out the constants. If 2 is there, you just pull it out and do this integration and then just substitute it back and just put it back at that place. And if you have I here, just pull it out with along with this 2 and just integrate it and just treat them as constants. So that's how we got this uh, answer. So this is your answer. So this is the required f of z. So we've constructed f of z. So we've constructed f of z using the Thompson method, given the real part, the imaginary part. So similarly, you can also construct, given the uh, real part, you can construct the imaginary part using the same method. If they give the real part or the imaginary part, using the same method and the CR equations, we can construct the complex function like this.